To begin, Hurricane Juan was a Category 2 storm that left behind much destruction at Point Pleasant Park in Halifax, Nova Scotia. The park holds much importance, not only with the flora it houses, but also to the Mi'kmaq people, as they designated it Amnu Tukadi, or the Place of Spirits. Previous research originally classified the park as belonging to the Spruce, Fir, Pine, Maple, Birch Association of Forests. Shortly after the storm, Neely and colleagues conducted a survey of the disturbed park and found that the majority of the park was composed of red spruce, maple, white pine, and some balsam fir. Most recently, Keyes found that the forest exhibited vegetation that was dominated by white birch, red maple, and bracken. The main issue with the above studies is that the classifications used are discontinuous and range in specificity, making it much more difficult to analyze the actual changes in biodiversity at the park. This is where we come in. Our aim was to further examine the succession at Point Pleasant Park. More specifically, we wanted to quantitate the changes in species diversity from year to year to estimate the stages of succession and the progression towards the climax community. To do so, we collected data from randomized quadrats from across the forest and estimated percent cover for ground flora inside these quadrats. Trees were subject to diameter at breast height measurements. Our research aimed to answer three main questions. First, how has the forest community's species diversity changed over time? Well, we hypothesized that species diversity has increased since the hurricane. If this is the case, we predict a positive relationship between Shannon Diversity Index, or H prime, and time since the hurricane. Our null hypothesis is that there was no change in Shannon Diversity Index since the hurricane. Second, how has the density of the dominant species in 2003 and that of the species in 2024 changed over time? We hypothesized that the currently dominant species must have a higher rate of density increase relative to the former dominant species. If this is the case, we predict that the linear rate of increase of the 2024 dominant species will be greater than that of the 2003 dominant species. Our null hypothesis in this case is that there was no change in density for both species since Hurricane Juan. And last, how has the species richness in the forest changed over time? Well, we hypothesized that species richness has increased since the hurricane. If this is the case, we predict a positive relationship between the species richness per unit area and time since the hurricane. Our null hypothesis is that there was no change in species richness since the hurricane.
In order to examine the secondary succession occurring, study sites were used. Each study site was 20 meters by 20 meters and dispersed throughout Point Pleasant Park, as you can see in the figure here. Trees and ground flora were examined to determine the changes in the forest community during its secondary succession post-hurricane. For trees, all living trees that were greater than or equal to 2.5 centimeters in diameter at breast length, or DBH, were measured at each study site and identified. This gave us an estimate of the amount of wood in a stand of trees. On the other hand, for the ground flora, the percent cover of each species of group of flora was sampled using 12 of the 1 meter squared wooden quadrats. The selection for the location of each quadrat was chosen at random, and by this I mean the center of each quadrat was determined by a ball being thrown behind someone's back, and wherever this ball landed was to be the center of the quadrat, and this ensured some unbiased randomness for each sample. As well, this was repeated for each site. And finally, a linear regression analysis was chosen for this study as it best represents the change for the forest community with respect to time.
We used a regression analysis to assess if there was any correlation between Shannon Diversity Index and time elapsed since Hurricane Juan. This is depicted in Figure 2. We found that there was a significant positive relationship between Shannon Diversity Index and time in years since the hurricane. This result supports our prediction, and we can reject our null hypothesis. We can then use the regression equation provided in the figure to predict the diversity index based on the year. From the data, we predict that diversity index will increase as we progress towards the climax community. The increased species diversity could be attributed to the takeover by numerous intermediate species from the pioneer species during succession. However, this rate of increase may halt as we near the climax community and the dominant species outcompete their counterparts.
These graphs represent the changing density of red spruce trees and red maple trees in Point Pleasant Park after Hurricane Juan using data collected from 2003 until 2024. The graphs show an overall trend of increasing density for both species. The red spruce tree had an increase in variance of 12.18% in 2024 in comparison to 2003, while the red maple tree had an increase in variance of 15.49% in 2024 in comparison to 2003. In 2015, the red spruce had a large increase in density compared to the red maple tree. However, the red maple tree density quickly caught up over the next 5 years and had a higher density than the red spruce around 2020. This spike in density levels for the red maple allowed for it to take over as the dominant species over the red spruce. Therefore, as predicted, the red maple has a higher rate of density increase, making it the dominant species in 2024 relative to the 2003 dominant species of red spruce, which has a lower rate of density increase. As the forest moves towards its climax community, the dominant species will increase in density. As shown in Figure 4, the increase in red maple starts approximately around 2009. Before this, Point Pleasant Park was still going through the earlier stages of succession, which are the pioneer and intermediate species. After these stages have completed, the climax community can begin, and the red maple that was shown to be the new dominant species in place of the red spruce can begin to grow in numbers.
Juan used linear regression to examine the species richness of Point Pleasant Park over time by collecting data on number of species within a certain area over several years. Within Point Pleasant Park, there was a significant positive correlation between the species richness and years since Hurricane Juan in 2003, which indicates that as time passed, species richness had increased. The R-squared value was 0.6051, which is above the threshold of 0.6 for strong correlation. Due to the positive correlation between the species richness and years past, we reject the null hypothesis and favor the alternative hypothesis that species richness has increased since the hurricane. Comparing the data over time, the average species richness is nearly 4 times more per 400 meters squared in 2024 than it was in 2004. This positive growth in species richness could be due to the ecosystem having more time to go through the stages of succession. Looking at the linear regression in Figure 5, R-squared is 0.6051. Therefore, time passed in years explains 60.51% of the variation in species richness. In a similar study by Xie et al., it was found that secondary succession initiated by Hurricane Fran had accelerated the succession process of pine forests in North Carolina to a later successional stage. The absence of the dominant or larger species allowed for less dominant flora to grow and develop in the uninhabited areas caused by these hurricanes. As the forest grows and matures, the continuous rate at which the species richness increases will begin to slow until it stabilizes at equilibrium once the species richness reaches its climax community. There are some instances in which a natural disaster is actually beneficial for the ecosystem in a specific area. As a result of Hurricane Juan, many of the larger plant species were removed, and this absence of canopy allowed for other species to grow and develop with more habitat area and nutrients than previously available. Between 2004 and 2010, there was a steady increase in the number of red maple trees per 400 meters squared, indicating an early successional stage, as seen in Figure 4. During 2015 onwards, there was an influx of tree density in both the red maple and the red oak, in Figure 3 and Figure 4. With this increase showing the transition into a mid-successional stage within the forest as it matures. In Figure 2, the Shannon Diversity Index shows an increase over time, indicating that the number of intermediate species is increasing as the forest moves forward through successional stages. The steady increase in species richness also indicates the forest moving through successional stages due to the continuous regrowth of flora throughout the area. The positive rate of regrowth into the most recent year of data collected suggests that Point Pleasant Park is still currently in mid-stage succession. The positive correlation between time and regrowth of the forest ecosystem is a significant indicator of successful secondary succession occurring and the ecosystem of Point Pleasant Park recovering naturally. It should be taken into account that invasive species are not excluded from the species richness models, potentially skewing the data obtained, as well as potentially preventing more native flora from growing in the area. The large decrease of richness seen in 2021 in Figure 5 could be related to the removal of some invasive species throughout the park. Another factor of being an urban park is human infrastructure, with the pathways built through the forest potentially taking away areas where species could be regrowing or maturing interfering with the forest's succession process. Cultural burning is an indigenous cultural practice that can significantly improve an ecosystem's diversity and management of resources. These intentionally lit, controlled fires aid to promote ecological diversity, as well as being a way for many indigenous communities to spiritually reconnect with nature. The philosophy behind cultural burnings refers back to the concept of fire as medicine. Similar to how modern medicine is prescribed, it is only applied in small amounts to maintain the systems and abundance of the ecosystem, while also improving soil quality and allowing the land to become more resilient. Use of small, controlled fires within Point Pleasant Park could aid in the continuation of the forest regrowth into maturity while promoting species diversity and abundance.
Question 1. How does Point Pleasant Park's status as an urban forest influence its forest succession? Well, the constant interactions between humans and the park would certainly have far-reaching effects on succession. These effects could arise from various causes and can impact the forest both positively and/or negatively. For example, succession may be affected by human infrastructure, altering the expected natural development of many species due to the additional stressors. This phenomenon is called fragmentation, which occurs when specific areas of the ecosystem are separated into smaller sections. This can influence the species in that area's ability to develop further and continue to regrow and repopulate the area. Human influence can also greatly affect succession due to the possible additions of invasive flora. There are several management reports that suggest the removal of exotic species will allow for better growth within the native species. This type of human interaction with the ecosystem can limit the ability of the forest to move forwards through the stages of succession and prevent natural growth. On the other hand, efforts to conserve the park, such as precautionary measures that counteract destructive storms, can help in preserving the flora in the park.
The long lifespan of the red spruce and its ability to withstand disturbances allows the tree to provide a canopy during secondary succession, aiding the red maples in growth. This is important for the red maples as they require a canopy to grow in due to its difficulty growing in open spaces. Additionally, red maples are a fast-growing species. Since they have their ideal canopy to grow in, it is easier for them to grow at the quick pace that they want to, and making it easier for them to become the dominating species. Burley et al. 2008.
Because there is no way for humans to reduce the severity of a hurricane when it does occur, we have to focus on reducing the possible damage that could be caused both to the forest and to the surrounding community. One way we could minimize damage is to reduce the possibility of loose branches and organic debris being blown around by a hurricane. In a study done by Stantorf et al. In 2007, it was found that spatial distribution and tree height were more important than the specific species for stem breakage due to high velocity winds. The close proximity of trees may aid each other in support and ability to withstand storms due to the overlap or collision of branches with one another, lessening possible wind force. Tree height may also be a contributing factor to damage, with taller trees being isolated and more at risk of wind damage. By pruning the canopy of certain trees, the wind turbulence can be reduced, as well as removing any weak branches that could fall during a hurricane. By allowing the forest to protect itself and managing the state of the flora and trees within it, we can better prepare for when the next inevitable hurricane arrives to mitigate any possible damage.
We would like to thank Professor Alison Schmidt and T.A. Tegan Robinson for assistance and guidance on this presentation, as well as assistance with fieldwork and data collection at Point Pleasant Park. In addition, we thank the Halifax Regional Municipality for the upkeep of Point Pleasant Park and accessibility to it. This work was also supported by Dalhousie and the Biology 2060 Introductions to Ecology Lab and Lecture.